got to push them apart. Exactly the opposite of two positives or two negatives. This is what makes charge different from gravity from last semester, because the two flavors of charge, we've got more scenarios we have to analyze. But the good news is, the rules are the same. It's just there's more ways we have to look at it. So far, good? All right, you probably have more questions once you actually try to do some of the homework. All right, I partially apologize for the last problem. There has to always be at least one tedious problem to make you glad you'll never see it again. All right? And basically, the tedious problem that we've got, so this is the equation for potential energy of two particles based on 0 and infinity. And they give me a problem where I have 3 charges, and they're all the same, Q1, Q2, Q3. Those are Q's. All right, they're all the same. And I take another charge and I bring it and put it in this location right here. Okay, and they ask me, what's the total potential energy of the system? How do I do that? It's literally this, and I know you're going to hate me, but that's okay. We may well start early on that. See this equation? It says to find the total potential energy of a system, you have to find potential energy of every possible pair of charges. How many possible pairs are there? There's 1, 2, 3, then 4, 5, 6. Oh, look, that's right here. It's 1, 2, 3. Right? So now that one we've done. Now that one's gone. So we have 3, and we're done with that one. Now we come here. How many? 1, 2. Right? And now we come here. 1.
What about the 2 going across?
So I do this one. I can go to this charge, and this charge. So that gives me the 3. That one's gone. Now I come here. That one can do this. And it can do this. Now that one's gone. And now it's just got 1. So you have to find every possible pair. So there's 6 terms you have to calculate. But it's not. I mean, it's tedious. It's enough to make you swear at the teacher a little bit. But it's something that you kind of need to be able to crank it through just even to think about it. I would probably, if I were going to do something like this on a test, I would not have more than 3 charges. Because if I have 3 charges, I only have 3 charges. It's the 4th charge that suddenly makes it 6. If I have 2 charges, I have 1 term. I have 3 charges, I have 3. If I have 4 charges, I have 6. And it gets nastier and nastier the more you go. All right, so I wouldn't do anything past that. But where you, in the comfort of your own home, you should be good. All right, so the basic ideas, just a little quick recap. We talked about conductors, and we talked about how charges are distributed on conductors. And one of the main things I really need you to understand is that any time that you have a conductor with charge on it, the charges will distribute, and we're doing statics. We're not doing wires of conducting, so what I mean by static is whatever charge you put on there distributes and no more gets put on there. Charges will distribute on the surface of a conductor such that there's no net force on any single charge. Because if there were a force on a charge on a conductor, it would move because it could move. That's the definition of a conductor. All right? And then, so we kind of just had to look at that. There's a polarization thing going on where we get charges separating. Do you all understand why the conductor with the conducting lines can never build up a net charge on itself? If I bring the charge nearby and I polarize it, fine, but as soon as I go away, because it's repelling and it's got a nice place to go, any excess charge that was there immediately disappears from the system. And so try to look at all this homework. Even if you don't get it all, read every homework problem. There's no penalty for doing that. Not do till Monday. Look at every homework problem before class on Friday. All right? And having done that, be ready to ask me questions. And I'll also go over the new problems that come from the next material after the stuff we've done for today. And yeah, it runs about this fast. So because you're all probably roasting about as much as I am. I'm going to let you go 5 minutes, but I'm going to stay for the whole 5 minutes to answer any questions. Some of you may have not been brave enough to